When you're solving inequalities with absolute value, you need to consider two different cases. So one of them is when you have a greater than, and one of them is when you have less than. So when the absolute value is greater than a number, you're going to break this down into two possibilities with an or in between them. When you have the absolute value of a number is less than, the absolute value of x is less than a number, then you're going to break this down into two separate problems, but there's going to be an and in between them. Whenever this is an and, you can also write it in this form, and I'll get to this more later, but this is going to be important for you to recognize, okay? So here, when the absolute value is greater than 5, we break that down into, so for this example, the absolute value of x is greater than 5. You break this down into x is greater than 5, so it's like you drop the inequalities, or x is less than a negative 5. So you change the direction of the inequality, and you change the sign of this value of the number you're looking at here. Okay? Now I want you to see when you graph that on a line, here's the x is less than negative 5 part with the open circle, and x is greater than 5 is over here. Your solution cannot be in both of these regions at the same time, so it means or. So your solution is on the left here, or it's over here on the right. It cannot be in both of those. Cannot meet both conditions at the same time. Okay? So it's important for you to remember that anytime you have the absolute value is greater than, or if its absolute value is greater than or equal to, that you're going to break this down into an or problem. Okay? Now, if this is the absolute value is less than, or less than and equal to follows this rule as well, then you're going to break this down into an and. Everything else is pretty much the same. X is less than 5, and x is greater than a negative 5. Okay? So x is less than 5. You can see that's going to be an open circle because there's no equal to part, and it's shaded to the left of 5. And x is greater than a negative 5. Here's a negative 5, open circle, and shaded to the right. Now the and means that it must meet both conditions, okay? Because if I said x is less than 5 or x is greater than negative 5, then my solutions would be anything to the left of 5, which would continue past this direction here, and anything to the right of a negative 5, which would be pretty much the whole number line, okay? And that doesn't make this equation true, the inequality true, right? A positive 6 here, I plug that in. The absolute value of 6 is 6. 6 is not less than 5. So only these solutions make this expression true, okay, or this inequality, sorry, true. Okay, so, and this means and. So whenever you write this as a combined statement, it means and. And if you notice, this part is written, this is x is less than 5, and this is x is greater than a negative 5. So when you're writing it in this statement, you always put the bigger number here on the right and the smaller number here on the left, and these inequalities have to be in this direction. Do you see what I'm saying? X is less than 5, and you read it in terms of x here, this is x is greater than a negative 5. So it's in between those two. Okay, so let's go look at a problem that you're going to get in ALEX for solving an inequality involving absolute value. Okay, so here's two examples. One of them is a greater than, and one of them is less than, or less than and equal to in this case. So let's look at this first example. One of the things I want you to realize here is that you need to kind of solve this inequality as far as you can so that the absolute value part is the only thing on this left side of the inequality. So we're going to solve it just like it was like if it was 3y minus 11. I would add 11 to both sides and then divide by 3. That's what we're going to do. So we're going to add 11 to both sides. So that's going to give me 3 times the absolute value of x minus 4 is, oops, sorry about that. Okay, got to put my absolute value symbol in there. Now I can do the greater than symbol. And we're at 11, adding 11 to both sides, so that gives us 21. Now we're going to divide both sides by 3. So when we divide this whole thing by 3, the 3's cancel. Leaves me with just the x, the absolute value of x minus 4. And that's going to be greater than 7. Now this is the absolute value is greater than, and so this tells me that I'm going to break this up into 2 problems with an OR. So I'm going to say x minus 4, just drop the absolute value, is greater than 7. We write it just like this looks, but without the absolute value. And then I'm going to drop the absolute value on the left side, but I'm going to change the direction of the inequality and change the sign of the number on the right, which is going to be negative 7. If you attempt to do this at the beginning of the problem before you add 11 and divide by 3, you're not going to get the correct solutions for this particular inequality. So make sure you solve it for the absolute value first and then separate it into the 2 separate problems. Okay, so now we're going to add 4 to both sides. So 7 plus 4 is 11, so we have x is greater than 11. And this one right here, when we add 4 to both sides, negative 7 plus a positive 4 is a negative 3. And these are your 2 solutions. Now, we need to do the same thing for this problem on the right. So we need to go ahead and isolate the absolute value first. So we're going to add 6 to both sides. So 14 plus 6 is 20. We're going to divide both sides by 4, and you get the absolute value of y plus 3 is less than or equal to 5. Now here we can divide this up into 2 problems. We know that this is going to be an AND because the absolute value is less than or equal to. Now, one of the things you can do is if you know it's going to be an AND, you can say it's going to be less than or equal to 5, just like we were dropping. We write it just like we were, like it is up here, but without the absolute value. And then you could go ahead and sandwich that in between 5 and negative 5 here. So this is y plus 3 is greater than or equal to a negative 5, okay, because we know it's going to be an AND. And when you do that, you're essentially solving, you're concentrating on the middle part, and you're thinking, okay, I would need to subtract both sides by a negative 3, but you've got 3 parts now, so what you're going to do is essentially subtract 3 from all 3 parts so that you can get y by itself. So this is y is less than or equal to 5 plus a negative 3 is a positive 2. And a negative 5 plus a negative 3 is a negative 8. So y is less than or equal to 2, and y is greater than or equal to a negative 8. This is your solution. Now, for those of you that you're looking at this and you're thinking, oh, I'm just going to mess that up, you could have separated this in this way. You could have said y plus 3 is less than or equal to 5, and y plus 3, change the direction of the inequality. It's essentially what you're doing when you're doing that, and change this part right here. And then change this to a negative 5. Okay, so it's pretty much what we did here, but we put an AND instead of an OR. And when you go to solve this, you're going to get the same thing. You subtract 3 from both sides here. You get y is less than or equal to 2. And subtract 3 from both sides here. You get y is greater than or equal to a negative 8. This means the same thing. These are the same.